Welcome to the third part of this series. In this series, we explore Egypt's 5 true pyramids through scale models I have built on a frozen Finnish lake. So far, we have learned that there are 5 true pyramids in Egypt, which together form 3 distinct ground plans. These ground plans manifest mathematical ratios in a way that cannot be a mere coincidence. Here is the Giza ground plan, consisting of 3 true pyramids. Within this plan we find square roots of 2, 3 and 5. Here is the Dashur ground plan, consisting of 2 true pyramids. This plan expresses the numbers 1 and square root of 5. And here is the Great Ground Plan, which encompasses all 5 true pyramids. The Great Ground Plan manifests the values of 40,000, 8,000 and square root of 5. These ground plans embody 8 intentional ratios, designed in either meters or royal cubits. This is presented in a manner that demonstrates clear intentionality and systematic design. Furthermore, we have learned that the royal cubit and the modern meter are linked into the same measurement system through the geometry of a circle with a 1 meter radius divided by 12. The meter and the cubit appear side by side in the architect's design, not only in the ground plans but also in the capstone of the Great Pyramid, discovered in 1982 by Rainer Stadelmann. Its height is exactly 1 meter and the perimeter of its base exactly 12 royal cubits. Now, let's examine these ground plans in more detail. Let's begin with the Giza ground plan. The side lengths of the Giza ground plan express the mathematical ratios of square roots of 2 and 3. Why these specific ratios? Perhaps because together they produce a total perimeter that is near perfect approximation of a unit circle's circumference. When we add the side lengths together and compare the sum to the calculated result, we reach 99.9% accuracy of the unit circle circumference. We have already seen that the pyramid architect favors circular geometry, so this discovery is fully consistent with our previous findings. Next, let's look at the Dashur ground plan. As we can see, square root of 5 is also present in these proportions, this time in meters. The short side length of 1000 symbolizes a unit side length. It can be read as 1 times 1000. Here, 1000 acts as the constant factor for the ground plan. In the Great Ground Plan, the first thing that stands out is the diagonal, which once again measures square root of 5. The short and long side of the Great Ground Plan are designed in precise round numbers, which is another clear sign of intentional design. The long side expresses the number 40,000 in royal cubits. Could this 40,000 symbolize the Earth's circumference, which by definition is exactly 40,000 kilometers? However, we must now take a closer look at the number square root of 5, as it is the only mathematical ratio that appears in all 3 ground plans. In Giza, you find it in the diagonal of the ground plan. In Dashur, it manifests as a side length, and in the Great Ground Plan, it appears once again as the diagonal. Why has the ratio square root of 5 been given such a prominent role? This number is exceptional because it is intrinsically linked to the Golden Ratio, a ratio that appears time and again throughout pyramid architecture. The Golden Ratio is denoted by the Greek letter phi, and there are actually 2 of them. The lowercase phi refers to the lesser ratio and the uppercase phi to the greater ratio. By examining square root of 5 more closely, we realize that its sum consists exclusively of these golden ratios. In other words, square root of 5 is the sum of the golden ratios. A line segment with the length of square root of 5 is perfect for demonstrating golden ratios that are hidden in it. However, dividing a line segment precisely according to the golden ratios is difficult, as you can see. This is where the so-called unit geometry comes to our aid. I don't know if there is a formal definition for unit geometry, but for many it is synonymous with sacred geometry. Some might consider this a side path, but I find it fascinating nonetheless. The starting point of unit geometry is a unit segment. By using the unit segment as a radius, we can create two intersecting unit circles. In a sense, we are now at the starting point of mathematics and geometry, which is why unit geometry is also known as sacred geometry. What does this figure now tell us? It introduces the ratios of square root of 2, 3, and 5, exactly those same ratios we found in the Giza ground plan. But the most elegant part is how the circle geometry bisects the square root of 5 at precisely the right point. Now we will draw a third circle with a diameter of exactly 1. It fits perfectly between the two larger circles. This circle intersects the diagonal at 2 points. For now, we only need one of these intersection points. Now the segment has been divided perfectly to reveal the both golden ratios hidden in the square root of 5. In the next video, we will delve into how the golden ratios appear in the pyramid architecture, so be sure to subscribe.